Okay, the time is now Pacific time, 9:05. We are going to start the presentation, and we thank you all for being here. Okay, this is our first Wefunder webinar for our investors, and please note again that this webinar is being recorded. I would like to introduce you to the Jetoptera team. Andrei is Jetoptera's CEO and co-founder. He is an aerospace engineer and inventor with more than 100 patents. A former GE engineer, he led the maturation and development of the world's largest turbofan engine in the world, the GE9X. He holds a PhD in aerospace engineering from Rutgers University. Simina, Jetoptera's CFO and co-founder, is a three-time founder and entrepreneur, as well as a former managing director at Merrill Lynch. She holds an AB from Princeton and a PhD from the University of London. And I am Todd, the VP of Business Development and a former Marine Corps Lieutenant Colonel. I have extensive experience in aerospace programs, business development, and defense aerospace at L3 WESCAM, UTC Aerospace Systems, and the development are in Textron Systems, and I hold a BA from Oregon State University. Our agenda for today is we're going to be sharing what we've been working on here at Jetoptera. We're going to present the investment opportunity, and then, of course, we're going to leave plenty of time for Q&A at the end. With that, I'm going to hand it over to Andrei. Andrei?
Thank you. If you can go to the next page, please. Hello and welcome to our webinar. I'm Andrei Evolet. In giving you an overview of Jetoptera's unique fluid propulsive system and its distinction in the aviation industry, we start with the problem we're trying to solve. Brief look at the legacy systems for vertical takeoff and landing, or VTOL systems, shows that they have common challenges. Legacy VTOL platforms are loud, slow, and complex. Examples include helicopters, who actually dominate the market, tilt rotor, which in spite of several decades of efforts has never penetrated the commercial side. It's only the military side. The Harrier jump jet, which has had a very successful past, but is now sort of obsolete. And the emerging market of electric vertical takeoff and landing. There is a massive opportunity to disrupt the vertical takeoff and landing and advanced air mobility market, which is expected to reach $1 trillion by 2040. Now, a particular challenge for the electric VTOL systems is that they're at the mercy of battery development. We expect this challenge to continue well into the next few decades. So in addition to noise, speed, and compactness challenges, an energy agnostic approach is necessary to ease this transition to lower carbon economies. If you go to the next slide, please. So here's where Jetoptera's innovation plays an important role. We're the world's only jet propulsion solution using fluidics. We eliminate the propellers. Instead, we perfected a new type of ejector that have several advantages over legacy systems. One of them is that by eliminating the propellers or rotors on the outside of the aircraft, we no longer chop the air, producing a noise at a certain frequency, which is the main production of noise for any of the legacy system. As a result of that, and we have data to prove this, collected over the past 4 years, we will be at least 30 decibel quieter than anything legacy system has to offer. And that is a huge advantage because that allows us to operate around the clock, whereas others are subjected to restrictions, very powerful restrictions in terms of what hours of the day they can operate in. Also as a result of eliminating rotating parts outside the aircraft, we have developed concepts that enable us to go 2 to 3 times faster than helicopters. And in fact, in past 2 years, we have demonstrated with validation from large aerospace companies that we can actually produce a vertical takeoff and landing aircraft with our technology that can go as fast as Mach 0.8. This is something that no eVTOL aircraft could achieve. And you can imagine a business jet that can also do vertical takeoff and landing. If we go to the next slide. So this novel type of ejector allows also for a better integration of airframe with propulsion. This is actually the name of our company. It's combined between jet and ptera, which means wing. So from the start, we wanted to do something, a propulsion system, to invent a propulsion system that is better suited and better integrated, as opposed to the normal approach of one company designing the propulsor and one other company designing the airframe and then bolting them together with a minimum amount of integration. The propulsion relies on a trickle of compressed air produced by mature technologies such as turbo compressors or turbofans. This has been around since the 40s, and companies that produce this type of turbo compressors and turbofans have reached really mature levels and reliability. The design of our ejectors enables a massive amount of entrainment of ambient air and its acceleration to produce thrust. Mass flow rate times velocity, that gives you the thrust. Now we can achieve levels of entrainment that are well beyond anything that can, any turbofan that can do a bypass of, say, 10-to-1 maximum. We have demonstrated in our test that we can do 20-to-1 entrainment, and we can engineer it to dial that number to what we need, to engineer it the way we want it. So we can engineer these thrusters to have non-round shapes. This is a huge advantage. And think about it for a second. All the legacy systems out there are something that rotates, and as a result of that, they're round and they have moving parts. We can depart from that limitation, and we can actually embed our thrusters better with the wing, for instance, to create extra lift. So we're in effect pioneering a combination of thrust and lift augmentation at the same time. We have demonstrated that in the wind tunnel. We reduce weight by using a single propulsion system for vertical takeoff and forward flight with no propellers and no other moving parts. You'll see that many of the legacy systems out there are utilizing propulsion system for vertical phase and a different type of propulsion system for the horizontal or forward flight. We're not doing that. We're minimizing the weight of the entire propulsion system this way. To add to that, our thrusters can be 3D printed, and because of the benign conditions of the compressed air supplied to them, we can actually go to metallic or non-metallic, such as thermoplastic materials that can be 3D printed. We have a strong profile and low direct operating costs. We know how a turbine operates, a turbofan operates, we know the costs, so it's easy to anticipate low direct operating costs. Our energy agnostic tech supports jet fuel, sustainable aviation fuel, and biodiesel today, hydrogen potentially in the next couple of years. If the hydrogen economy takes off, we're ready for it, but also hybrid and electric power in the future, as the system is a distributed propulsion system using compressed air provided by either mechanically or electrically powered turbo compressors. In fact, 2 years ago, we have already demonstrated an electrically powered compressor or a booster supplying our FPS thrusters in a test that was sponsored by the Department of Defense. Our technology is scalable to support aircraft anywhere from UAVs to manned aircraft to business jets and beyond. Just imagine a VTOL capable business jet that can also do a Mach 0.8. It's a game changer. And with that, we can go to the next slide, where Simina is going to cover, Todd is going to cover some other progress that we've done. Todd?
Thank you, Andrei. One of the things is we are taking off as a company as far as our research and development, our different programs that we're involved in. And we've been awarded over 91 patents, and we have another 100 plus that are pending. We have investment from the government it's 3.1 million in different contracts and RDT&E projects, which is research and development, test and engineering, with the U.S. military. We have invested of our own earnings and private funding of $10 million into R&D, so research and development. So that's what's enabled us to be able to do tech demonstrations and testing in wind tunnels and static, and also we've actually built several different types of aircraft to test the different theories and methods of airframe design to date. And you can capture those on YouTube and other sources where we have posted them. We have collaborated with lots of different people within the DoD. We regularly work requirements and programs that's directed by US SOCOM, that's United States Special Operations Command, and Air Force Special Operations Command, who originally saw what we were doing and said, hey, we got something that we could really use that type of capability. And we've also were awarded as part of the high-speed VTOL AFWERX challenge. So those of you who may not understand what AFWERX is, it is a defense innovation unit marketplace where they have created these innovation centers of excellence to push funding of R&D projects out to small businesses. And basically it's anybody can come in there and present a technology and the government will take a look at it. So we've been a benefactor of that. And on the high-speed VTOL challenge, we were awarded a phase 1, and then we were down selected and also received a phase 1A. So that was a very exciting thing. We've also been working with industry giants such as Northrop Grumman and Pratt & Whitney. And with that, I'll take it back to you, Andrei.
Great, thank you, Todd. Let's talk a little bit about the path to commercialization. First of all, as Todd mentioned, we're very proud of our history. We founded the company in 2015. Between 2015 and 2018, we tested a number of paths of our technology. 2018 was the year where we actually started flying with our FPS on 3 different platforms. In the meantime, from 2018 to today, we have secured 7 contracts with the Department of Defense, mainly with the US Air Force, but also some subcontracts to other companies for the US Army. We've been approached by several large and small aerospace companies for engineering services, meaning that included deployment of our system on either existing UAVs that these companies had or developing new systems for new aircraft. In 2022, we sold our very first system to one of the large aerospace companies to power one of their drones. We've been working for the past 4 years on a system that silently powers parafoils for either cargo or manned applications. This is called the Powered Parafoil FPS. In 2024, we pursued development of a cargo VTOL in the 500-pound class, as well as the high-speed VTOL version called Hedwig. As a reminder, this is a development that is capable of not only vertical takeoff and landing, but also capable of flying at Mach numbers beyond 0.5. This is better than the tilt rotor, for instance. The focus is, however, on the J2000, which is the major effort, and notably, we have ordered the power plant for J2000. This is under work today, and that is targeting to fly the prototype in 2024. By 2025, we'll be able to offer you the J2000, potentially under the light sport aircraft rule from the FAA. We will accept paid aircraft build positions at that time. Also in 2025, we will be testing the prototype J4000, the larger version. In 2026, we'll launch our commercial certification program for the J4000 with a view to commercial sales by 2027. This means that if all goes well, you could be sitting in a J4000 by 2027 or a J2000 by 2026. By 2027, our FPS will be integrated into other aircraft configurations, not necessarily VTOL, potentially general aviation, from parafoils to fixed wing, unmanned and manned, adding short takeoff and landing to their conventional takeoff and landing capabilities, thanks to our proprietary, proven fluid propulsive system plus upper surface blown wing tech. This is, we have patents on this technology. We've been demonstrating in the wind tunnel. This includes also adjacent markets that may not be very obvious today, but may be very significant, such as the wing in ground effect, fast ferry capable of speeds of over 150 miles per hour, meant to serve the coastal transportation. Here in the Washington State, especially, there's major need for something like this. This is technology we've already demonstrated under DoD contracts over the past 3 years, proven to perform better than the distributed electric propellers approach everyone else is deploying. So if we go to the next page, let's talk a little bit about the Flagship J4000. J4000 is positioned to be the first useful air taxi. And what do we mean by that? First of all, our technology distinguishes itself from the rest, and will enable vertical takeoff and in some cases short takeoff and landing. Why is that important? Because in some of the regional air mobility markets we see, serving suburbia might actually allow for short takeoff and landing as well. I mentioned already that we're the quietest propulsion system in the skies by at least 30 decibel compared to the most silent propeller or rotor. And that is important because we can operate around the clock. We offer maximum speeds of 200 knots. Maximum payload for the J4000 will be 1,000 pounds. That includes 3 passengers, pilot, and some luggage, with a maximum range of 500 miles. Why is this important? It's important because we can serve, for instance, multiple routes and multiple transports of passengers on the same tank. So basically we don't have to recharge, or we don't have to stop and take a long break and recharge our batteries, as eVTOL challenge exists for those competitors. With this system, the autonomy for hovering is 1 hour, fully loaded, and it will be by far safer and more compact than any other competitor. That itself, the compactness and the lack of large rotors, will also open up other destinations and locations we can land and take off from. So really something that we look forward to, and to revolutionize air transportation. Back to you, Simina, to talk about the market.
Great, thank you. If you could have the next slide, Todd. So we're at the center of a market that is forecast to grow to $1 trillion by 2040. Before we get there, we are just benchmarking the opportunity today. We would characterize ourselves as a category killer, as Andrei indicated, for helicopter applications. So what's the shape of that in looking at 2022? The addressable market, going from the bottom up, that we've identified is a couple of $2 billion on the military side. Most importantly, it's $49 billion in helicopters, $30 billion in commercial drones. We're in a position to disrupt all of that. The one sector we won't compete in are the tiny drones that take photographs of your house. There's also the general aviation category, another $25 billion, that in that case comprising both physical sales and services. Fast forwarding to 2040, and this is based on Morgan Stanley research, we've got, again, a $10 billion, let's call it sliver, for our particular capabilities as identified by the DoD, but the lion's share is the transport and logistics sector and the autos shared mobility. And I would submit that there's a symbiosis there. That market doesn't grow without capabilities like those offered by Jetoptera in terms of safety, noise profile, range, weight capabilities. So we think that we actually will help make that market come to its full potential. So what are the requirements of that market? Aircraft using FPS can operate around the clock and land in tight spaces where large rotorcraft cannot. There's no runway dependency. There's almost no limit to where we can fly to and land safely, and also when we can fly and land safely. So if we can go to the next slide, a little more detail on thinking about the potential applications. On the public safety side, especially EMT evacuations, high value deliveries. That's a very important part of the our offering. Frankly, both manned and unmanned. Logistics, you've got last mile delivery, you've got the increasing need for less than truckload economic delivery. Both in remote and also in tighter, more urban or suburban locations. Then you've got the general surveillance and long-range inspection, which is also quite important. And then general aviation, going everything from the light sport aircraft to the what we fondly call the air taxi applications, all the way to the business jet category using our adaptive fluidic propulsion, as Andrei indicated. One thing that is not perhaps in the Morgan Stanley forecasts, but we see it as being part of our future, is the wing and ground effect, high-speed ferry competing sector of the market. So if we go to the next slide, just our big revenue step, because commercial certification is the hurdle on the manned side. Our big revenue step is in 2027. And if we look ahead to 2028, just focusing on the things we know how to build right now. You've got the J family, the sort of box wing, but sort of futuristic looking aircraft that you see in the picture, going from the 2,000 pound to the 4,000, 6,000 and up. You've got the unmanned cargo sector, and then the other two pie slices. You've got the high-speed VTOL in 2028. That's a military application that we think that's going to make the leap to civilian with our business jet offering. And then the J-pads, the powered parafoils, again, that's a more military application, at least in 2028. And we think our growth from there is going to be exponential beyond 2028. So that's the path that we're on. Just one more detail on our revenue mix. We think that long term, we're going to be looking at technology licensing for the military side and sales of sort of nose to tail commercial products on the commercial side. As Andrei alluded to, our current raise is going to be deployed largely towards that J2000 prototype. That's going to be our first flying commercial prototype that we have, in fact, we have the components in order right now. So we think that truly the sky's the limit for us, and we would very much invite you to take flight with us.
Everybody, thank you for putting your questions in the Q&A. We really appreciate it, and we hope to get to all of them. So one of the questions from an anonymous attendee is, are you looking to invest and partner with global companies, R&D that develop solid state batteries for higher density? Andrei, you want to take that?
Sure, sure. One of the things that we have to acknowledge is that we are not a battery company. And the battery development, during my time at General Electric, I had the opportunity to work in a technology hub that was looking at any type of energy storage, energy production, propulsion, and so on. It was a lab that was covering all of these. I've seen a lot in a number of technologies, including battery. And I can tell you that battery development is a unique and very expensive and very painstaking approach that we do not want to entertain at this point or in the future, because we're an aerospace company. Companies like Panasonic and so on, Varta, those are the companies that will develop the future technology for batteries. And think about this, the battery has been around 200 years. That's 100 years more than aviation. Having said that, we are very open and absolutely capable of accepting any advanced battery that exists out there that is, number one, energy, specific energy capable and comparable to actually produce a mission that is useful to the customer. Number two, safe, okay? The more you pack in these chemical batteries, the more energy you pack in there, the more dangerous you make them. I believe that one of the speakers from MIT did point out that these batteries are considered in some Navy applications to be too dangerous to store on board, in spite of the fact that they have missiles on board. So the more energy you pack in these batteries, the more dangerous they may become to start the fire or an explosion. We're going to watch this thing, and we're going to be, when we're going to be offered a battery that is capable and safe to operate in the skies, we'll be ready to accept it.
Thank you. Again, from another anonymous attendee, what was the driver to go to military route as opposed to focus on the commercial consumer and civilian route?
I mean, sure, that's a very easy answer. It's I think the military knows exactly what the missions exist and what they have, and the advantages that our technology offers. Just to name a few. So it was a little bit like low-hanging fruit to go military first. The military likes to use jet fuel. That's what we use. The military knows turbine technology. That's what we use, turbo compressors. Moreover, it's a huge advantage for certification purposes, because the data we collect in all these military programs will help us streamline the process of certification down the road. And lo and behold, you know, when you go to a military space to fly, you have less restrictions than in a commercial frame. So I think these are a few of the elements that we preferred military first, but Todd, feel free to add to that.
Yeah, so please understand that when I came on board, my background was in airborne sensors. I worked for L3 Westcam back in the day, and then I went and did a whole bunch of other intelligence community activities to include my active duty. And with it, we saw a lot of frustration amongst us in uniform of how loud and logistically painful it is to operate all the different UAVs that are in the DoD inventory. That said, I recognize that, you know, one of the things we wanted to do is generate revenue. So, you know, that was one of the things I said, hey, you know, right now, we could take advantage of how loud everything is. The solution to Jetoptera, when I saw it, I was like, that's awesome. What a great thing. If I didn't have to worry about a rotor strike and doing my, you know, hovering over an area or trying to get, you know, injured personnel in and out of an area, like in an emergency medical situation or a medevac, that is totally useful. Also, if I needed to get ammo delivered across the battlefield, that is a definite use case. On the civilian side, having that, how many times have we seen an air ambulance helicopter have a wire strike or other vertical and you know trees and everything else, power poles come down and have a rotor strike or a tail rotor strike. And if we could eliminate that, how many people can we save per year, and how much are their lives worth? And since I've had personally lots of friends that were killed in those accidents, that was a big deal to me. So I think there's lots of different ways to include logistics distribution. Wouldn't it be great to get a set of pizzas delivered, straight from your favorite pizza joint and have it done very quickly? I think so. Other applications are, if you're a commercial ship and you're 20 miles out of port and it costs too much money to your company to, have one part that's the size of a shoebox go back and forth, you're not going to turn the whole ship around. And if you could have something that can come in, fly, land, and not have to worry about, the guide wires or crashing into anything else, that would be a needed application as well. So that's
And
why we went to the military route.
So if I can jump
speed.
in there also, we can't lose the sight that the short answer is also money.
Yeah.
The military, our technology is dual use. A lot of commercially useful things came out of military applications historically. And the beauty is that we're getting paid with non-dilutive capital to develop the technologies that we want anyway. A perfect example of that is high-speed VTOL. Getting paid to develop that, we're going to turn it into a business jet application.
Yeah, and keep that IP.
And yes, completely. Yeah, we keep the IP.
And then thank you, Dragos, for those questions. Anthony Peterson, you had a 2024 prototypes, full size. What would the empty and max weight of these vehicles be?
The rule we use for all our J series vehicles is 25% fuel, 25% payload, 50% rest of the aircraft. So if I were to use the definition of useful payload for a J4000, is going to be 2,000 pounds, meaning passengers and fuel. For the J2000 is going to be 1,000 pounds.
Thank you. And then Clay Lambert writes, "Hey, Andrei would be a great speaker on Graham Plaster's DoD podcast." Yes, he would. He's done a lot of TED Talks, so that would be great. And he's done a lot of briefings to AIAA. And people love to hear about the technology, why it works, how it works, that type of thing. And he's all into it. So yeah, we'd be interested in that. And we're familiar with Nautilus program at Defense Works, but you know what? We've been so busy with our head down doing engineering and business development and growing the company sometimes that those things escape us. So thank you, Clay, for that. Donovan Poland, when you get a chance, have you also filed PCT on the patents? And if so, which countries? Andrei.
Yes. So you have to remember that the strategy for developing an IP portfolio, what is a patent? A patent prevents other people from making our technology, for producing and selling our technology, right? So we targeted international countries, locations that have a traditional aerospace manufacturing or aerospace technology. So yes, the short answer is yes. We have a very large PCT portfolio. Those over 90 patents cover international patents, not only US. Of course, we secure US, but it's also Canada, it's also Brazil, Australia, UK, Europe, and these countries that have a large tradition. China, actually, we do have several Chinese patents.
Israel, Japan, and of course in Europe you've got Germany, Spain, France, UK, Italy. So yeah, we've been comprehensive in our pursuit of the IP portfolio.
And down the road, we might actually license to some of these countries to manufacture our technology.
Yeah, India as well, of course.
An anonymous attendee states, will you open up more platforms to invest in your company coming from Ontario, Canada? Yes. Since you know that I work for L3 Westcam, I'm familiar with Ontario, Canada. Obviously down at in a different part in Hamilton and Burlington, and Guelph region. But at any rate, yes, I believe Wefunder is available to Canadians. And if it's not, we'd like to understand if you're having challenges there. But definitely we want investment from Canada. So thank you for that question. Gene Katz, 30 dB means reduction by 1,000. Andrei?
Yes, it does. It's a log scale. Actually, over the past 4 years, I had the opportunity to learn myself much more about noise and acoustics that I ever wanted to know. But here's the thing. Yes, we have full confidence on that. We have measured the noise in our system two different ways, both accepted by the industry. One is in the traditional anechoic chamber. The other one is we retained one of the top scientists and specialists in aeroacoustics who actually got the AIAA prize 3 years ago for his contributions to establishing a new method of measuring noise. This method was applied to our system and compared to an equivalent turboprop. And this is a specialist who actually told us, and I asked him if we can use this phrase and quote him on this, like, your device as designed will not sound as a machine. It will sound more like the wind. Those were his words. So the fact that we're eliminating frequencies, low frequency, high frequency, but particularly low frequency noise, it's extremely important in propulsion. Remember that the noise of a system that uses propeller, whether electric or internal combustion engine or turbine, the main noise does not come from the engine. It comes from the propeller. That's the dominant noise. You eliminate that and you have a game changer.
Great, thank you. We have some more questions. We want to get to the rest of them. So let's bang through these. From Clay Lambert again, what is the lift to thrust ratio as it compares to traditional directed thrust solutions, Harrier F-35? Is it greater, comparable, inferior? I'm wondering if your solution enables greater armor hardened propulsion capabilities. So, Clay, when you say hardened, I think nuclear hardened. So if you're coming back, we can't discuss that. But Andrei, go.
Yeah, so I think it's interesting to compare with the two systems that were mentioned. First of all, the Harrier. The Harrier was what we would refer to a brute force. In other words, they were using the jets by deflecting them, orienting them downwards without any augmentation. What we mean by augmentation is a multiplier of that thrust. Our technology is different. Our technology takes that jet and multiplies its thrust twice by entraining massive amount of air and accelerating that air. So if I were to say the Harrier was an augmentation ratio of 1, our system, by using compressed air, will actually produce twice to 2.5 times more thrust based on the same power of the system. For the F-35, it's a little different because they use a turbofan that is for the vertical takeoff, a specialized turbofan that has the role of actually only vertical takeoff or landing. However, remember what I said earlier. It's very important you have a system that is doing both functions, vertical and forward flight. The F-35 is not doing that. That fan in vertical is only activated via clutch in vertical flight. When it starts flying horizontally, it's just dead weight. Okay, and it's quite a lot of quite a lot of weight. So compared to F-35, F-35 is a larger aircraft than what we have in sight right now. A business jet is more appropriate for our technology. That's not to say that we're not going to look into the future for other systems as well.
And thank you. Just remember the F-35 is a short takeoff only, right? And then vertical
Well,
landing, short
yes.
takeoff,
Yeah.
and it does not take off vertically. So
well, it could take off vertically if it doesn't have any payload. So
yeah, if it could take off vertically if it doesn't have any payload and you have just enough fuel to fly maybe one pattern and come back. Okay. Can you elaborate from Antonio Mendoza? Can you elaborate more on the autos shared mobility market? What kind of applications would be utilized in this market?
Thanks for the question, Antonio. So the autos and shared mobility market are just a fancy way of saying what Elon Musk said: if you want a flying car, just put wheels on a helicopter. And not to be flip about it, but we from the J2000 all the way to the J6000, 12,000, etc. What we have is aircraft, piloted aircraft that can take off in urban, both urban and suburban, and also runway unavailable spaces, and go point to point, being both runway and airport independent. We are stressing the manned aspect of this because one of the benefits of our technology, unlike VTOL, is that we don't have to rely on autonomous flight and pilotless craft to have meaningful ranges and payload. So essentially, anywhere you would like to use a helicopter, plus places that helicopters can't go, our target target space.
Okay, thank you. Clay Lambert, you said, can your thrust method of thrust be applied to hydrodynamic applications? Answer is we've done some limited things there. But if you want to talk to us more about that, we'll discuss that offline. We're not going to discuss that here. Zoom user, what is or are you thinking of your limb factors, limb facts on the company's speed of progress toward its objectives? For example, are you limited by need for capital, need for technical talent resources, the speed at which the FAA will move in certifying something else? So our limb facts, I'm sorry, I abbreviate things. Our limiting factors right now is really just capital. That's it, because we're not limited by technology at all, be fast or slow. So
just to jump in here for briefly, I'd say that talent is not a problem, and I'll give you an example. We had more than 1,000 applications for 4 positions in the past couple of years, and they keep coming. Okay, our location also is very, very good right now because of the proximity to large aerospace corporations like Boeing, Blue Origin, and so on, and also the school and computer science talent, local talent. So we have no problem with recruiting talent, and we're very, very picky about it.
Scott Johnston asks, looking ahead and taking the example of a basic helicopter, so R-66, right, or Bell 20647, how do the acquisition and operating costs compare?
Yeah, so we're unapologetically using turbines for our applications. So from that perspective, we would be comparable to a turbine powered helicopter. However, and that's a big however, we utilize the turbo shaft in a different manner. In other words, we're turning that into a turbo compressor, meaning that we deal with deal off with, we no longer use reduction gear and all that stuff that actually limits the life of the system for a helicopter. Less moving parts, less weight. That is replaced by another system of conduits that feed our thrusters. So I think that if anything, the direct operating costs will be lower than a helicopter by quite a number. Also, the turbo shaft, technology is very mature and very well understood. So we think that we're in a very good position there.
Okay, Clay Lambert comes back and it says timeline for FAA. We discussed that. 12,500 single pilot general aviation solution. And do you have a ballpark price target for that? No, because we really haven't, taken a look at that, but I can't see us being drastically different than a standard general aviation. If you're talking 12,000 pounds being too much off that mark. The neat thing is I think our maintenance is going to be a lot better because if you compare it to a helicopter, there's no balancing of rotors and transmission systems. So that's a fun thing.
One observation of the FAA is that we actually had them reach out to us about a year ago, saying that they'd heard about us and they were curious. They requested a briefing. We ended up having 80 people on the phone. So we think that they're aware that our technology is coming down the pike, if you will. And so, obviously we're going to make sure we keep them as well briefed as we possibly can as we progress.
Yeah, there's a question here, if I may, about who in the industry, Anthony Peterson, who is pursuing hydrogen power plants. There's a couple of names. Rolls-Royce is doing that. They tested recently a system on hydrogen. There are others, smaller companies, Turbotech in France, which we purchase systems from them, and they have a plan to deploy hydrogen. The hydrogen thing will be ready for it. There's no question we'll be ready for it. I personally have experience of 200 hours while I was at GE of firing hydrogen in a gas turbine. And I can tell you right now, it's a very, very, very challenging system to deploy to aviation. Even for cars, for fuel cells, that's one thing, but for gas turbines, scalable and all that, because it comes with all kind of issues.
Okay, so anonymous attendee, do you have any intentions of flying at supersonic speeds?
Yeah. Well, okay, so our system that we developed for Mach 0.8 could be adapted for that. We actually talked about adapting our power plant to actually operate in what is called super cruise conditions. However, the statement is not that simple. It's not only related to power plant. It also has to do with the design of the aircraft. Once you go to a supersonic aircraft, you have to modify a number of things, including the thickness of the airfoils and reduction of that drag and so on and so forth, which conflict in a way with deployment of the FPS. So we thought about it. We are waiting for the DoD to offer an opportunity to work on that further.
Let's see, from Nick Kuros, will exit be one and done, stock value, or fragmented, as in different applications, military versus commercial, and licensing? Simina?
Well, I think that conflates a couple of questions, which is how will we generate revenue, and and there will be licensing streams as well as manufacturing and sales streams. The question of the financial exit, it's early days. One can contemplate an IPO, one can contemplate a sale, and one can, as I think you're suggesting, Nick, contemplate basically selling off the military division and IPOing the commercial. It's too early to tell, but right now we're focused on getting to that revenue inflection point.
But thank you for your question. Are there any competitors that you worry about, maybe because of their technology or better funded? And I'm going to say absolutely not, because right now, we don't have competitors in fluidic propulsive systems because we are the only aircraft that is powered by fluidic propulsive systems. Why? Because, you know, Andrei invented it. So
Well,
that's where we're at
well,
there.
it's we're also protected by the IP, so we're not worried about that. We don't think the electric path forward is going to continue. The momentum is going to continue too much into the future because there's some reality checks that are viewed right now by the industry. So we really think that the next step there will be to revert to a hybrid system from all battery, and we're not worried about that at all. So.
Thank you. Francis Craven, is Jetoptera looking to become a dedicated airplane manufacturer, marine engineer manufacturer, or are you just looking to license bigger organization as well? How do you expect to raise plus or minus $1 billion to build an airplane manufacturing facility? Does Jetoptera have an exit strategy or sell? So, okay, we get this question a lot, and the best thing we can say is yes to all the above because we need to generate revenue. We really enjoy working with different aircraft OEMs. Why? Because they already have all those certs in place, and we do wonderfully well integrating our design, our propulsion system with their, best of class aircraft designs. A lot of times that aircraft design will be morphed quite a bit because of the unique capabilities. Okay. Thank you for that question. Alexi, for J4000, is the flight plan to be fully automatic? Will it have manual override? What pilot certification expectations? So right now we are doing unmanned aircraft. We have optionally manned aircraft, and we're going to be going to regular manned aircraft. So I think, again, it's the needs of the customer. So thank you for that question. We only have a few minutes left here. Donovan Pullen, in agriculture, there's a potential large market which would be easier from a regulation point of view, given it could be used to deploy ag chems on set programs.
That's a market we can easily serve. So yes, it's on the radar, but but in terms of what we're going to be focusing on first, that's going to be the crop dusting is a corollary. That's low hanging fruit once we have the thing craft.
I think the time's up here. I want to thank you all for participating, and rest assured that your questions, if you can post them on Wefunder, we will address all of them. Then if posting as a Q&A in answers for Wefunder works the best way because it's a response to everybody, so everybody can see it. So we'd like to invite all of you to invest. FPS opens up new applications to unlock the massive potential of $1 trillion market. That's not what we said, that's what Morgan Stanley said, and so on. So join us in building the next generation of aircraft, please, and visit Wefunder Jetoptera to invest. Thank you very much.
Thank you all for your time and your wonderful questions. Again, we will do our best to answer some of these on the Wefunder application and our Q&A. Thank you for your time today, and we look forward to speaking with you soon.
Thank you.